Hello everyone, our team is 25 and our project is ASL finger spelling. We developed one project that can record videos and recognize ASL word sign from the videos. Our project divided to the four parts. First part is extracting key points, and the second part is cropping algorithm, and the third part is 3D machine learning model, and the fourth part is segmentation and combination algorithm. Okay, let me introduce the first part. At the first part, we use the Postnet open resource project. Then we download it. At this project, we only use two parts. First part is frame extractor, and the second part is scale to the videos. And the frame extractor part, we just need to copy the path that store all the videos to here. Then run this part code. The code will generate frames that related to each videos, like here. Then we only have the videos before the running code. Next, we will get the folders that have the multiple frames after running code, like this. Next, we will use the scale to the videos part. At this part, we do the same thing. Just copy the path that store all the frames. Then run this part code. This code will generate the key point related to the each frames, like here. So I'm not run this part code as there because generation key point needs a long time. I'm not do this action. Xinyi will introduce the second part.
So I am going to talk about the prompt detection algorithm, mainly the image cropping algorithm. Here is our image cropping algorithm code. We wrote it in Jupyter Notebook. Since running everyone's data will take a lot of time, I am going to take one alphabet from one of our members as an example to show that the algorithm is fully functional and show how the result will be. I took part of the code to this Python file in order to run it more easily. I will use the alphabet A from Chinwen's dataset as an example. To specify, the frames for the video and extracted key points JSON file and CSV file have been saved in this testing folder under member's name. So here is the dataset I am going to use. Here is the result, and all cropped images are saved in this folder. Validation is done with respect to visual analysis. Around 80% frames can be cropped correctly. In the implementation, we use the Pillow, Image, OS, Globe, and JSON libraries. First, we specify the labels to represent 26 alphabets, and for each of our members, we first do image cropping for alphabet signs. So we loop through each alphabet sign video frames folder, and in every folder, we first load the key point JSON file to obtain rest key point for each frame. X and Y values for left and right rest key point will be fetched. Since we suppose that the hand to make the sign will have larger Y value, so we compare Y value between left rest key point and right rest key point. If left is larger than or equal to right, then we suppose the cropping range should be based on left rest point. Otherwise, it should be right. We then read each frame's image. Since 4 of us took videos using different devices, different distances to camera, and different backgrounds, we had to find the best crop range for each of us, instead of using an universal crop range. So the crop range used in each of our videos are different. We calculate left, right, top, and down based on the rest key point to decide the top left corner and down right corner of the cropped image. We use the crop function in image module in pillow library, and we rotate the image to make it vertical and save it. Same for words. We loop through the folder for each word, read the JSON file to obtain raised point and crop each frame. The same algorithm is applied to each of our videos. So here is our prompt detection algorithm and image cropping algorithm.
Third part and the fourth part in our project, which includes 3D CNN model segmentation and combination. We use OpenCV to load the image and we use Keras to build the 3D CNN model. For the input shape of the 3D CNN model is 16, 16, 16, and 3. For the first 16 means 16 image, and the second and the third one means that the image size. For the last 3 mean the RGB layer for each of the image. We use Kaggle as our alphabet training data as our training dataset. We resize each of the image to 16 multiple 16. Then for the 1 to 16 image, it will be the first training data. For the 2 to the 17 will be the next, and then so on. We also split the training data into the training data and the validation data for our model. Here is how we build the model. We set up an early stopping because they are not greatly improved in the training process. Here is our model summary. And this is our training process. We have set up with 40 epochs, but we do not run that much. In this process, we stop at 14. This is the validation score and the loss for our training data. The loss is 0.55 and the accuracy is 0.84. Now we are going to predicting the label for each of the video. For the first method is that one video will receive only one predicting label. During the sliding window for the testing data, there are lots of labels for it. We use the voting method to decide the final prediction label for the video. Then we can see the result of it. The result of it is 0.048 for the F1 score, and the confusion metric is like this one. The next method is that we do not combine the result of the sliding window, so that each of the video may receive many predicting labels. For the F1 score, it's like this, is 0.049, and for the confusion metric, it's like this one. Now we are going to talk about the word recognition. This is the word list for our members. There are also two members that we use to build the word recognition. For the first method is that we do not use the segmentation, then predict the label for each of the sliding window. If the prediction of this slide window is not same as the previous one, we add the prediction letter to the prediction list. Finally, combine them together. As a result is shown, like this one. The word length is longer than the actual word. So the next method is that we use the segmentation for the sliding window. We slice them into several parts with them based on the length of the word. For example, we slice them into 3 parts for the word R, A-R-E. Each of the parts will be based on the prediction label and do the voting to decide the present label. Then we combine the result together. So in this time, the word's length is same as the actual word. Here is the result of the prediction. However, the word we predict do not have a pretty match to the actual word, so we have used another method to calculate the accuracy. The next method is that we look up the predicting letter is in the word or not. If it is in the word, then the accurate letter plus 1. For all of the accurate letter to divide the total letter in the word list, the accuracy is 0.14. Due to the result of the alphabet recognition is not pretty well, we do another experiment. In this process, we use the testing data as the training data, which means that we use the video that is shoot by us. Then we split the data into the 40% with the training and the 16% with the further testing. And we split again for the training data to training data and validation data for the same model. Here is the same model, and there is also the training process. The result for the validation data is that they have 0.26 loss and then 0.92 accuracy. Then we use them to based on the first method with one label for one video. And then here is the accuracy of F1 score is 1.0, and here is the confusion matrix. Then the next one is we run it with the second method with a sliding window. For this one, the accuracy is 0.93, and there is also the confusion matrix. So with the result, we can discover that the training data and the testing data in our dataset are not quite similar. Maybe we can modify the testing data which need to be same as training data by taking photo, not video. For the word recognition, during the frame extraction in the postnet, it may not always extract the right frame that we are presenting the letter. It may also extract the time that we are moving. If it do not always get the right place that we are presenting the words, then the noise may influence the accuracy. This is all of our project. Thank you.